Hello grade 9s. In today's video, we'll be introducing exponents, laws of exponents. Knowing these few laws of exponents is the first step to making math simple and easy to understand. To each law I introduce, I'll give two examples to help you understand the law and also how to apply it. So, without further ado, let's get to it. Law number one is when you multiply when you multiply the same bases, you should add the exponents. And it could be demonstrated this way. So, law number one. So, let's say m times m, a, n. This should say it's a, m plus n. So meaning if the bases are the same, in this case the basis is a and a are the same, you should add the exponents. In this case it's m and n. So it gives us this as an answer. A is equal to m plus n. Let's take the examples now. Our first example, let's say it's x to the power of 2 times 2 times the power times x to the power of 3. Then according to law number one, it says if the bases are the same, keep the exponents. So in this case, our bases, it's x and x. So our answer here would have to be x, not only x, but now we have to add the exponents. Meaning now it's 2 plus 3. We can write it 2 plus 3. Then for an extra step, now you can say x is equal to 5. 2 plus 3 is equal to 5. Let's take another example. So let's say in this case you have 2 to the power 2 times, let me use this one instead of the dot one, to the power of 4. So here's the second example. So in this case, we have the bases which are the same. Our bases being 2 and 2. Then what do we do with the exponents? Our answer now would have to be 2. We keep it as it is. Then now we say we deal with the exponents. 2 plus 4 will give us an answer of 2 to the power of 6. And that's how we apply law number one of exponents. Let's go to the second law of exponents. So the second law is, the second law is when you multiply two of the same bases, you subtract the exponents. So in this case, I would use our base as a again, m divided by a n. Let me change color for this. It's division now. So in this case, the second law states that when you divide the bases, or when you divide the same bases, you subtract the exponents. So the answer here would have to be a, you keep it as it is, then with the exponents, what do? We subtract them. It's m minus n. Now let's take the examples. Our first example will have to be x to the power of 7, say x to the power of 7, divided by x to the power of 5. To the power of 5. So you see me change color for this. So the second law states that if you divide the same bases, what you do the exponents, you subtract the exponents. So keep the base, we subtract the exponents, meaning it's x to the power of 7 minus 5. So 7 minus 5 is equal to 2. So x is equal to x to the power of 2. And this is our answer for this example. Let's take a second example. Second example is a to the power of 3 divided by a. Yes, divided by a. Let me name this one. Example number 2, what to say. Let the division line not scale you. This is another way of writing a to the power of 3 divided by a. It could be written this way, it could be written this way, or this way. But they're both the same thing. So what is the answer to now? What is the answer to our example here? So the bases are the same. Base is a. What do we do with the exponents? It's 3 minus 1. So we assume there's a mathematical 1 here. That's where the 1 comes from, the 1 here. So our final answer would be a 3 minus 1. This is 2. Then a to the power of 2 is our final answer. Let us go to law number 3. Law number 3. So law number 3 is pretty easy to remember. Law number 3 states that any number to the power of 0 is equal to 1. So in this case, this is law number 3. In this case, any number, let's say our number in this case is represented by a. And let's say this is to the power of 0. What is our answer here? It states our answer is equal to 1. That is what it says. So we'll take 2 examples. First example would be y to the power 0. What is our answer here? Our answer is 1. In the example, let's say we are asked what is the answer to this equation here. Our answer is still 1. So yes, that's law number 3. It's very easy, it's pretty straightforward. It doesn't have too much calculations. Yes, you just have to remember that any number, that number could be any number, 30,000, 30,000, as long as it's to the power of 0, it equates to 1. So yes, that's what you gotta remember. Fourth law. So the fourth law states that any number to a negative exponent is equal to a fraction. So in this case, let's say we have a, which is our base, or represents our number, then n, negative n, is our negative exponent. This is said to be equal to an exponent, which can be written in this way: 1 over a to the power of n. Not to the power of negative n, but to the power of n. Let's take a few examples to help you understand. Our first example says x to the power of negative 2. According to the law, this should be equal to 1 over x to the power of 2, not a negative 2. Let's take another example. Always here. Let's say for a second example, let's say it's 2 to the power 2. Power negative 2. According to the law here, our answer would have to be 1 over 2 to the power of 2, not a negative 2. I hope it makes sense. Law number 5. Law number 5 is demonstrated this way. This way. This then means that for a base with an exponent, if there's an exponent outside that bracket, the exponent inside and the exponent outside, they would have to be multiplied. Meaning the answer to this one here would have to be a m times n. They would have to be multiplied, not added to each other, but multiplied to each other. Let's take an example. x equal to, and outside as an exponent, it's 3. What is our answer? So according to the law here, both the exponents 2 and 3 would have to be multiplied together, but we keep the base. keep the base as x, then 2 times 3. 2 times 3. Then this will equal to 6. This will equal to 6. This is what the law. This is what the fifth law means. Second example. Let's say we're given a to the power 5, or let me change this and make it 3. And outside here we have a 5 as an exponent. What will be our answer here? So our answer here would have to keep our base. Sorry, it's not x, it's a. Our base, then we multiply our exponents, 3 times 5. And what is our answer here? Our answer is a to the power 15. That is our answer. Let us go to law number 6. Let me erase here. So law number 6 is more of a continuation of law number 5. You will see as we go on. So law number 6 states that if we have a base, or we have two bases actually, and an exponent outside, now the exponent will have to multiply the exponent inside, and another, we have to multiply the exponents inside for each of the bases. Meaning for base A, it has its exponent, imaginary exponent being 1, m would have to multiply. And also B, base B, having its imaginary exponent being 1, will have to multiply by m. So meaning our answer here would have to be A to the power of m, and B to the exponent m. Let's take the examples to help you understand. So the first one is 2x to the power of 3, and outside it there's a 2. What is our answer to this one? So we know that there are two bases here, 2 and an x. Then we know that this 2 will have to multiply with the exponent here, and also have to multiply with this exponent here. So meaning our answer would have to be 2 to the power of 2 and x 3 times 2. This is equal to 2 to the power of 2 and x to the power 6. Let's take a final example. We have a to the power 2, b, and all to exponent 4. Our answer here would have to be a 2, let me write it as 2 times 4 times 4, b times 4 as well, just like that. So answer here is equal to a to the power 8 and b to the power 4. And that will have to be our answer. And yeah, these are the laws of exponents and how they can be applied. There are only 6 laws you have to know. The order doesn't really matter. Just know them and how they work. From here, I challenge you to write these laws in your own words And the next video will be activities where we have to apply these laws. And yeah, that's all about today's video. Don't forget to leave us a like and a subscribe. See you on the next video.